When we're doing astrophotography, we need to have some sort of control center for our equipment. So some sort of software that can control my camera, that can control my focuser, my filter wheel, if any, that can control my guide camera, that can control my mount, that could potentially control things like a flat panel, this kind of stuff, or even a rotator. And depending on the choice that you make for this tool, what you're able to do with it, like the amount of features that are available, the limitations, etc., are different. A lot of people, when they start in the hobby, they go for the excellent and very easy to use control center that is called the ASI Air. It's a one-stop shop where you have a single box with power outputs, USB outputs, and the software to control your equipment, but it does restrict you to ZW cameras, ZW guide cameras, ZW filter wheel, ZW rotator, and ZW focuser. It has a large number of mounts that are supported, as well as DSLRs to some extent. But it does mean that you're restricting the universe of equipment that you're able to use with that control center. At the same time, I personally think the ASI Air lacks a lot of very convenient features, especially when you're using a monochrome camera. Things like filter offsets, the ability to take images with one filter, then the next, then the next, then the next, all in a loop, so that you always have like all the colors that you want to capture, even after a single night of imaging. It can have issues with longer focal length, etc., etc. So there are limitations to the ASI Air. And if you are limited with the ASI Air, I see a lot of people looking at other potential solutions, such as using a mini PC with Windows installed on it, and then you can put the free and open source software called Nina, and Nina can control everything. It has a huge amount of features. It is, once you've set it up correctly, very easy to use and can be fully automated, so that you could basically like click on a button and then everything is done automatically, including copying the images taken over network to your processing PC, for instance, using a plugin for Nina. And of course, it supports pretty much any piece of equipment that's out there that has either a native or an ASCOM driver for Windows, which is pretty much every single piece of equipment for the hobby. Plus, via some plugins these days, it can offer some surprisingly capable smartphone interfaces, and it has a lot of good stuff going for it. The problem with Nina is that there is a learning curve, and it's not easy to just pick up, especially if you're a beginner in the hobby, or you're very used to something like the ASI Air, because then the paradigm changes, and there's a lot of things that you need to get used to until you have it configured exactly how you need. And this video, I hope, is going to be a masterclass for Nina, so that you have everything from the installation to plugins, to how to do plate solving, to focusing, to advanced sequencing, everything in a single video. And so that's going to be likely a long video. I'm probably biting off more than I can chew, but if I publish the video, it probably means that I'm done. Maybe I'll just end up publishing it in pieces, but let's get to it. And let's start with the initial state. I'm making the assumption that you already have a mini PC or any PC that you're going to use to control your rig, and that you have Windows installed on it. And ideally, you also want to have something like Remote Desktop, Chrome Remote Desktop, TeamViewer, that kind of software set up on the PC so you can access it remotely. And if you're not sure about how to set up the PC, I have complete videos on the topic, so I'll put a link up above and down in the description. The instructions for hotspot are a bit old, but besides that, it's still very much applicable in terms of the flow. But now you have your mini PC, it has Windows on it, and it is time to install Nina, so let's do that together. Okay, I'm on a remote PC, which is actually my Gaius S2 computer. It's both a mini PC as well as a power box, dew heater controller, and it has tons of USB outputs. So I'll put, by the way, a link to my review of that mini PC up above and down in the description. Excellent thing for Nina. It also comes pre-installed with Nina, so you normally do not have to take the steps that I'm going to take, but just so you know. So I'm connected to that remotely, and I am on the page of Nina. I'll have all of the links in the description, of course, where I have my the requirements, which gives you actually a good list of what you need to install to have Nina ready for you. You need the ASCOM platform, and the ASCOM platform is basically just a platform that can support various drivers for your equipment. It says it's recommended. I would say overall it's a must. PhD2 guiding, which is the software that will let you auto-guide your scope so that when you're pointed at a target, you can use a secondary camera and scope or off-axis guider to really keep track of what you're pointing at, so you can take very long exposures without issues. Or you could use meta-guide guiding instead. Most people go for PhD2, myself included. Then you can choose one plate solving application. So plate solving is basically just saying that when your telescope is pointed somewhere, the Nina can instruct the camera to take a picture. The camera will take a picture, and the plate solving application will analyze the stars in that picture to determine exactly where the scope is pointed. So that's what plate solving is. Things like the ASI Air do that automatically. For us, we need to install a free app. And I personally recommend either ASTAP or, if you have a long focal length, PlateSolve 3. But we'll get to that during this video. And we can also install planetarium application. I personally don't really do that, and this is very optional, so I will not cover that in this video. And also, we have the Sky Atlas image data. This is some additional data for Nina when you are choosing a target to image. Do you want to have like a preview of what that target looks like, yes or no? If yes, you want to download the Sky Atlas image data. I highly recommend doing so. But let's get to it in order. We first start with the ASCOM platform, which is available at ascomstandards.org. At least, again, we'll have the links down in the description, and we can just download and install the latest version. So it's already downloaded. I actually have an older version installed, so it will be a good opportunity to install for me the latest version. So I'm just going to double click on the installer for the ASCOM platform. And I do recommend running it before you install Nina. Okay, we have the installer window here. We do want to basically keep the default options. We don't need any of the out-of-date stuff. So I can just click on install and let it do its thing. Okay, and after quite a bit of time, the platform is installed. So I'm going to click on finish. Now, it would be tempting, now that we have the platform that supports drivers, to go ahead and install drivers, but actually no, it's better to install Nina first, and this is because a lot of drivers these days are bundles that contain both ASCOM drivers and native drivers, and it will try to find Nina, and if it does find Nina, it puts driver in there. If Nina is not installed, it doesn't find Nina, it doesn't put a driver in there, you do not collect $20,000. Etc., etc. So we need to download and install Nina. So I'll go to the Nina download page, and I'll just install the stable version for now, although already the 3.2 nightly versions are working perfectly fine for me. But out of precaution, let's go with the stable version. So I can just download it from here, and it gets downloaded here as the Nina setup bundle as a zip file. And I can go in there and say like, yeah, I want to extract everything into its folder, have it opened once it's done, and then I can run the installer for Nina in there. Okay, so in there, I can just agree to everything, click on install, and everything will be done automatically. It's freeware, it's open source, it doesn't install anything weird on your computer, just Nina, and it works great. Okay, here we go. We can launch it for the first time, which can be appropriate so that you know that it has like created all of the folders that it needs to create, etc., etc. So let's just launch it, and it will launch as it shows right now, something like this, without any real details in there. So let's, it's launched, everything's ready. I'm just going to close off Nina, and then we can go to the drivers. So drivers will obviously depend on the equipment that you have. For a lot of people, you would have like ZW equipment. So what you'd want to do is just go to zwastro.com/software and download the latest camera driver and download the latest ASCOM driver, which can be good to control your electronic focuser, your mount, your filter wheel, etc. So you want to download both the camera driver and the ASCOM driver. And you can see I have both of them, so I could just run the ASCOM setup for the ZW equipment that I have. And I can choose, what to install, whether it makes sense to install all of that, which, why not? I'm just going to have everything on the computer. It will remove first the old ASCOM installation that I have because I'm just showing you how it's all working. And we can proceed with the installation. Okay, let's click on Finish. We're done with the ASCOM drivers. We do want the camera drivers as well. So I'm going to double click on the cameras installer. Again, it will tell me like, okay, you have already installed because it's on this system. I'm just going to install it again just to show you. And we're going to validate install, and it does everything on its own. Finish. We're done with the ZW stuff. But you could have other cameras. You could have cameras from TopeTech Astro. So in this case, you would go and search for the TopeTech Astro software, and you have the ASCOM driver here. And actually, even though it says ASCOM, in terms of TopeTech, it actually installs the native camera drivers as well. And so you can go ahead, download it, install, and it will install all of the drivers. Just again, I'm removing the previous version, installing the new version because it was already installed on this particular computer, but for you it would likely be new. And finish. There we have it with TopeTech stuff. There's one thing with TopeTech is they also provide like DLL files, which are like basically raw driver files without an installer. And if you ever have a TopeTech camera that doesn't work after installing this driver there, another thing that you could do is download this DLL, which they tend to update fairly often. And with that DLL, you can go to C, Program Files, Nina, that's the default installation folder. Then you go to External, X64, because I assume you have a 64-bit computer, as most people do these days. And then you can put the DLL in TopeTech and rename it to topecap.dll. So I could, download this. You see it downloaded topecam x64.dll. So what you would do, you would take the DLL that you've just downloaded, rename it to remove the x64 here, and then you could drag and drop it to the folder we just looked at. I'm not going to do that because it's already, I know it's working, but that is something that you can do if you ever have trouble with TopeTech cameras. There's other equipment that you could be looking at, for instance, like QHY-CCD cameras, where you can go for the download. Again, they have like a full package, either a beta version or a stable version. And if you were to install the, let's say, the beta version, I think this is what I have here. Again, it would simply be opening that up. Although for QHY, we do have something a bit specific about them, which is that it will ask you to select Nina during the installation, and also it tells you to close all camera connection applications and disconnect any QHY-CD device cable before doing the installation. So actually absolutely do that. Do not forget to do that. It has caused issues for me in the past. So we can go next, still validate, and this is the important stuff. You have the drivers that you want to install, and then there's this third-party software support. And this is where you want to say like, oh yeah, actually I want my ASCOM drivers. I want ASCOM driver for the QHY filter wheel. And if I have an older filter wheel, maybe I want this one as well. If I have SharpCap installed, I want to select SharpCap. And then, very important for us, if I have Nina installed, I want to select Nina there. And if you don't select Nina, especially if you have something like the Minicam 8, which is very recent, which means that the stable version of Nina typically does not come with the driver that supports the QHY Minicam 8, then if you don't select this here, the QHY Minicam 8 will not work within Nina. So for us, it would really be like selecting all of those before installing. Now I already have the QHY stuff installed, so I'm not going to proceed, but that's something to remember if you're doing QHY stuff. And then you want to install anything you need for your equipment. For instance, I have a flat panel from RB Focus, and I can install it via the RBF Excalibur setup.zip. I also have a WD-20 mounts from Warp Astron. So I'd want to go to Warp Astron and go ahead and download the driver for my mount, and that will be an ASCOM driver. I could go to support, software and driver, and you can see I need to actually download two things for this particular mount. The COM driver, which basically lets the computer identify that the mount is connected, and then the ASCOM driver that lets ASCOM, and therefore Nina, communicate with the mount. So you would go both steps before it's available. I've already done this on this PC, so I'm not going to go through the details, and it's also very equipment oriented. But if you had, like, let's say a Skywatcher mount, then you would go and get the SynScan drivers, or better, something like Green Swamp server, which is what I use to control my Skywatcher mounts typically. So you would go in there, download it, and then you'll be able to actually control your mount using the Green Swamp server software. But this is like the drawback of supporting all of the hardware that is available on the planet, most of it actually. It's that you need to install the drivers separately, whereas something like the ASI Air comes with all of the drivers pre-installed. Even stuff like the Toptech Stella Vita or the StellarMate Pro have the drivers pre-installed, so it's a bit of a Windows thing. But let's say we have everything installed in terms of drivers. We're very happy about that. So the next step would be what? The guiding. So we would go to PhD2 guiding. Here we go. And I would just go download the latest version here for Windows, and we can just double click to install it. Okay, so let's run the installer for PhD2. I'm gonna say Windows, yes, you can run it, it's safe to run. And we can install just as usual. Okay, now that I have PhD2 installed, actually, rather than launching it directly, I would recommend, since we have installed all of the drivers, to restart the PC once. So I actually already restarted the PC, and we can launch PhD2 guiding. I'm also going to right click on it and to say like pin to taskbar, so I have it always available to start. And on first launch of PhD2, it should come up with the new profile wizard here. So we're going to go into the profile wizard, and it will first ask me to choose a guide camera. And my guide camera is actually a ZW camera. So I'm going to select that, and it asks me whether it's already connected. I'm going to say yes. And it has detected it. It is the ZW ASI 220mm guide camera. And what's very important here is to set up the guide scope focal length. So if you have a guide scope, put in your guide scope focal length in there. If you're using an off-axis guider, it should be the same focal length as your main telescope. And for me, I'm using the Carbon Star CS150 from Apertura. And so with the coma corrector that does a little bit of reducing, it's around 570 millimeters. And that's important so that PhD2 knows what one pixel corresponds to in terms of angle of the sky covered by that particular pixel, so we know how accurate the guiding is. So I'm going to click next, and now it's going to ask me for my mount. So for that, it's going to be an ASCOM mount, and specifically, it's going to be an on-step telescope because my WD-20 would be on step. For you, you need to choose the correct driver for your mount. And if the mount is already connected, you want to click yes, because it's also going to set up the mount guide speed, which is also somewhat important. And now it's connecting to my mount, and it is connected successfully. And it did read from my mount that the guide speed is 0.5 sidereal, and for some of you it will be 1, but most of the time it's 0.5. And you can change that in the mount settings, sometimes in the driver as well. So if you had like a Skywatcher mount, you'd be using Green Swamp server. If you were using a ZW mount, you would select ASI mount in there. But the principle is the same. I'm going to say next, and then there's like adaptive optics, none. There's a rotator, I don't use one, but if you did, like the ZW CAA, you would select it here, click next. And you could build a dark frame library if you wish to. I'm not going to do that right now because it's raining outside, and yeah, I don't want to risk opening up the equipment or whatever. But it is good to actually have a dark library, and I would recommend doing so. But otherwise, don't bother with it. I also want to suggest to select Auto Restore Calibration because that's a nice option to have, and I'm going to call this equipment like WD20 CS150. Right, this is what we're using. Click on Finish, and that's it. Now sometimes the flat wizard, or the wizard when you launch PHD2 can have some bugs. If it closes on you, you can always access it again by going to this kind of like USB icon here, and then here you can select New using Wizard. And now that I'm in there, by the way, I'm just going to connect everything. So I'm going to connect the guide camera, and I'm going to connect the mount as well. And there it is. It is connected, so I could, cycle through my frames. Right now, the camera is mostly covered, so we see only a little bit, tiny bit of light. And I can also go to View and say that I want to display the chart, and that will show me the guiding chart for declination and right ascension. And I can also display things like the star profile and all sorts of information that can be available. All of that typically is not super needed, but it's nice to have in there like that. Nice little PHD2 interface, and we can only use it to calibrate it once we get a nice clear sky. So I'll go back to that in a bit once I'm able to really go under a starry sky. So PHD2 is working. I'm going to stop the imaging. So if you want to start, the frames taking it this double arrow. If you want to stop it, it's there. And then you have additional settings under that brain icon. Typically, you don't need to really change them because we've already set them up correctly in the wizard at the start. If you have a strain wave gear or harmonic type of mount like the ZWAM5 or my own, the WD20, you'll want to have an exposure length of 1 second or even 0.5 second. If you have a traditional mount, with like a standard worm gear kind of mechanism like the AQ6R from Skywatcher, something like that, you can select up to 3 seconds, and that's what I would actually recommend if you have such a mount. But for us, it's strain wave gear here, at least from my rig, so I'm going to select 1 second and put that in icon. And now I will go back to the Nina requirements list to see what else we need to download. Okay, so we have PHD2 guiding installed and ready to go really, but now we need to also install a plate solving application. So as I was mentioning earlier, I recommend either ASTAP or PlateSolve 3. And if you have normal telescope, normal focal length type of stuff, ASTAP works great. But if you have a long focal length, let's say 2000 millimeters, Schmidt-Cassegrain is an Edge HD 11, for instance, which is like what, 2800, something like that, I don't remember. Very long focal length, especially if you pair it with small pixel cameras like the 585 sensor or the 183 sensor. You absolutely want to use PlateSolve 3 because ASTAP will not work well with that. So you have the choice between the two, and you can actually install both if you ever need them. So ASTAP, you need to install two things. You need to download and install the main program of ASTAP, and you need to install and download the star catalog, star database. And if you want to be safe, just go for D80. It's going to be 1.3 gigs of installation space of download to do. If you have a fairly wide field rig, as I do, then D50 is enough. But if you want to be safe, just get D80. And then you want to just install in order, starting with ASTAP. So I've already downloaded ASTAP. It should be there. So you want to first run the ASTAP setup. And I'm going to run anyway. Here we go. And it's already installed, so I'm not going to go through the whole process, but that's what you would do. And then the next step would be to install the star catalog of the star database. You can see I have here the D50 star database, but likely you will have downloaded the D80. It's exactly the same thing though, so you can just run that as is, and it will detect the folder where ASTAP is installed. That's why it's important to install the main application first, and you would just click next, 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 etc. For me, I don't need to do that because it's already installed, so I'm going to exit the setup. Now, if you went with PlateSolve 3, rather than using this link here, which brings you to a huge download page that has a lot of stuff that is very unintuitive to use, I would recommend instead going under the documentation, advanced topics, plate solving, and then scrolling down, and I'll put the link again down in the description, but you should have PlateSolve 3 here. And in here, you just need to click on this and download this particular file. And then you want to just install it. But that's limited to if you have like a long focal length rig. Typically, you would not need it. Although, if you are switching over from the ASI Air to Nina in order to support a long focal length, because the ASI Air can have trouble with that, then you definitely want to install this. So that's PlateSolve 3, and that's some of the software that we need. Going back to the prerequisites, I already said like a planetarium application, I don't use one, so we're not going to install that. And then there's the Sky Atlas image data. So I can click on that, it actually brings us to the main download link. And you just want to go to the very bottom, and you have the offline SkyMap cache here, 3.3 gigs that you can download, which I've already done. And it is this zip file here. So again, I would just go ahead and extract all as a folder. Oh yeah, I'm going to show the extracted files when complete. It's going to take a bit of time because it's a large archive. Okay, we have it unzipped, and if we open up the folder, we'll see that it's just a series of JPEG files, a lot of JPEG files. And what I like to do is to just put it somewhere I'm going to remember, and we'll be able to set up Nina to have a look at it. So I'm going to Control X to move it to Documents and validate that, and we now have it in Documents. And now we should be ready to launch Nina and set up Nina. So we've already installed ASCOM, we've installed all of the drivers, we've installed PhD2, we've installed the plate solving software, we've installed the Sky Atlas preview basically, and we've installed Nina. Everything is ready, so let's launch Nina and go through the first setup to get really everything dialed in. So I'm going to select Nina in my start menu. I'm also going to pin it to the taskbar so I can use it anytime I like, and let's launch it for the first time, see what happens. I mean, actually second time, because we've already launched it once before installing all of the camera specific drivers. Here we go. So we are here and we have several tabs here, and we're going to basically go through each of them in turn. Okay, so we are in the equipment tab of Nina, and we have a list of equipment that we could just connect to. And after you've connected once, Nina will remember that. So it's a kind of like a one-time type of deal, although I like to kind of do it manually every time I launch Nina because it brings me closer to my equipment. It's a psychological thing. But we'll start with the camera, and in theory, if you open up this drop-down, you should see the cameras that you have connected to the system. This one is the camera for PhD2 for guiding, but my main camera is the QHY Minicam 8. If you do not see your camera in there, it might be that there are no native drivers for Nina, in which case you can choose the ASCOM version of that camera. Or it could be that the USB cable has issues. It's not plugged in well. It's not given 12 volt DC, for instance. This camera, the Minicam 8, will not show if I don't have 12 volt input into it. That kind of stuff. So you do need to double check what's happening there in that case. And after you fix the issue, you can click that refresh button for Nina to recheck which cameras are connected to the system. For me, it's the Minicam 8, and I can just connect to it. And you can see I have a default gain, default offset, USB limit, and then the cooling capability on the right-hand side here, as well as readout modes, which I like to have as full resolution. And in terms of gain, it's just like on something like the ASI Air, you need to choose the correct gain for your camera. If you're using something like 2600 MC or something like this basically, or 6200 MC or MM, or a 533 camera from ZW. I would recommend gain 100. If you're using the QHY Minicam 8, I think 80 is the gain at which the high conversion gain is triggered, so I'm going to choose that. And you might have things like full resolution, or if you're using Taupe Tech, you'll have like the choice of low conversion gain versus high conversion gain directly in these options. All of that, it's nothing to do with Nina really. It's all about your camera itself. So you want to check your camera specifications to see what would be the right numbers to use in there. The only thing that you do need to set up yourself is the offset. And the offset is basically, what you can do is, I have a video on the topic, so I'll put the link down in the description and up above also if I don't forget, where you can basically cool the camera first. So to cool the camera, you can have Nina do it automatically when you start a sequence, but you can also do it manually. I could say like, okay, cool to -5 degrees Celsius here, and then click the cooling icon there, and now it will start to cool the camera. After you've cooled the camera, place the dust cap on. Make sure there's no light leaks of any kind. Then just use the imaging tab, we'll get to it later, to take 1 second exposures and just change the offset until you find the lowest value of the offset that allows you to not have any pixels with a value of 0. That's how you set your offset. And it's an option that is not available in the ASI Air because ZW sets it automatically for you. It sets a value that is a bit higher than optimal, but that way it's sure it's going to work with every single sensor or variation of the cameras that they have. The offset, if you set it too high, it will compress a little bit the dynamic range that's available for your camera, but it's not a big deal. Okay, let's go to the next tab, which is the filter wheel. And for me, again, this is a filter wheel that has a native driver. So it's available directly in there. But for a lot of people and a lot of filter wheel, including ZW filter wheels, you would need to select ZW filter wheel in there and then click connect. I don't have that. For me, it's the QHY Minicam 8. I could try to connect via the ASCOM driver and, click on connect, see what happens. Yeah, it has issues there. I think it wants me to connect the camera via ASCOM in that case. So I'm just going to go for the native driver, click on connect. And you can see we have our filter wheel connected, and it has detected all 8 slots of my filter wheel, but they don't have any real nice name yet. Don't worry, we'll be able to change that soon. Then I can go to my focuser. My focuser is based on an ASCOM driver, and it is a Gemini focuser. So it uses my FP2 ASCOM driver there. So I can select that, and I can click that little gear icon as well to see the ASCOM driver parameters, including the port that is going to be used to connect to the focuser. If you ever try to connect a focuser or a filter wheel and you do this and it gives you an error message at the bottom right, chances are, for me it just worked, but chances are you need to change the port that is being used. So for instance, I can show you how it would look like. Let's say I've selected the wrong port. I can try to simulate that. Let's select COM1, click on connect, and then I'm going to try to connect to it again. I think it will give me an error. There it is, like unable to connect. In which case you want to go inside the ASCOM driver and select each port you have on your computer one after the other until it works. Again, it's a one-time thing, not a big deal, but it is something to do at first. And you can see that within this, you can see the current position of the focuser, and you can change the position either by setting a value in there like 50-50 and then clicking move, or you could use the arrows underneath here to do a small movement or a large movement. The values of that are in the settings, so let's not do it yet. Then you could do the same for a rotator. I don't have one on my rig, so I'm not going to connect a rotator, but I can connect my mount. And for me, it's going to be the on-step telescope mount. For my particular mount, I can click on the gear icon, and you can see that for me, it's going to be on COM6. Apparently, I have a lot of parameters in there. But again, those parameters have nothing to do with Nina, everything to do with the mount. I just have my limits in there. that I have set up already in the past properly, and I'm just going to connect to the mount. Now this will give you a dialog where usually it will tell you like, hey, your mount has some coordinates set up in it. Do you want to sync with Nina? And you can choose whether the mount coordinates are correct or the Nina coordinates are correct. For me, the Nina coordinates are 0, so they're incorrect, and the mount is actually correct. So I'm just going to say from mount to Nina, and that will actually upload or update the position that I have in Nina to whatever the mount has in its parameters. Okay, so the mount is connected. I can go to the next one, which is the guider. And the guider, I can just select PhD2 because we have PhD2 installed. And normally, after selecting PhD2, you can just click on the connect button and it should connect to it. If PhD2 is not installed, it's not launched, it will actually launch PhD2 automatically and start going through the frames of PhD2. So just for the heck of it, I've closed PhD2 and I'm going to connect to it from Nina while PhD2 is closed, and you can see that it launches PhD2, connects to the whole equipment, and then starts looping the images. So we're ready with PhD2 connected to Nina. And then for me, my particular computer, the Gaius S2, has a switch where I can control the power ports of the computer. And that's, for me, an RB focus power controller switch. And again, I can check the gear icon to select the proper COM port and then connect to it. That lets me control the power ports directly from within Nina, and those can be controlled from within the sequence as well. And finally, I do have a flat panel that can be controlled via USB. That also is a flip-flap type of panel, so I can like open it remotely. It acts as a dust cap for a telescope, and it's going to be RBF Excalibur. And again, you need to select the right COM port in the settings, but I'm going to connect to it, and now the flat panel is connected, and I can open it, close it, change the light intensity, the brightness of the light, etc., etc. Now I can control everything, and we have basically all of our equipment connected. Of course, for you, you will have different equipment connected. This is probably the hardest step because everything has to work. Everything has to be plugged in correctly. You have to find the right COM ports. You have to have the power working. And this is probably the steps where you will have issues. But if you've installed the drivers carefully, especially like QHY, Select, Nina, that kind of stuff, it should work. And here it has worked without too many issues. Okay, so now this is for the equipment tab. I'll go to the next tab, which is the Sky Atlas. And the Sky Atlas, we don't really need to use it right now, but we could say like, okay, let's search for M32, and it tells you like when it's gonna rise, assuming your coordinates are correct. But remember, we synchronized the mount coordinates to Nina, so they are, and you can also, slew to the target, set for framing assistant, or add target to the sequence to take an image. And you can filter all sorts of stuff in there. I'm not going to spend too much time on there, but you could say that, okay, I want to have like an object that is above 30 degrees altitude from whatever, like 10 p.m. to, let's say, 2 a.m. And it should, it will be visible for more than 1 hour, and I can select an object type, etc., and then click search. I'm going to remove M32 there, click search, and it will suggest a lot of potential targets that follow these criteria. And here it is. And notice that we don't have any images yet. This is because in the settings, I have not yet set up the image catalog that we downloaded and unzipped earlier. Then we have a framing wizard. Framing wizard is very similar. But right now it's not yet usable because we need to first set some things up in the options. So we can go back to it later. There's a flat wizard. I'll go back to it later, but it lets you basically take your flat frames automatically super easily, and in my opinion, much more easily than the ESIR, especially if you're using monochrome and multiple filters. Honestly, it's kind of magic. We have the sequencer. I'll go back to it later because this is where you can plan your sequences. And there's a simple sequencer and an advanced sequencer. The advanced sequencer is absolutely amazing, and we'll get back to it later. Then we have an important tab, which is the imaging tab. And this is where you can really, like, we've already connected all of the equipment, right? So I could ask Nina to take a 1-second exposure with my camera using this imaging thing here, and you can see 1-second exposure. And I clicked here to take one exposure, and you can see the minimum value is 1472, although I don't have the dust cap properly on, so it's kind of invalid. But I could be changing my offset. Actually, I think for this camera, an offset of 8, if I remember, was a decent value. So I could go back to imaging, take a 1-second exposure, and here we go. Now, like, the minimum value is 48, pretty decent in terms of setting my offset. But in here, you have a lot of options that are available. You'll have like sequence information, star size, and autofocus information. You'll have an image history, and you can have multiple tabs within a single window. So I could say, like, I could click on this autofocus thing. It will add an autofocus control tab, and I can actually drag and drop here and say that I want this to be part of this window by selecting the center or by hovering. I'm still clicking here, and as I release here, bam, I have autofocus and image as 2 separate tabs here. And I can, move them around as well. So image is the first one, then autofocus, and I have other options in there like plate solving. Bam, I can add plate solving, and again, move it to the center area to have it available as a tab, and I can do plate solving of my targets from here. So that's like the kind of like the control center for Nina in general. And now we go into the options, and that's really where we need to do the initial setup. So first things first, you have the profile here. And the profile is basically an equipment profile. You can have multiple of those. And I could say this is like CS150, so my Carbon Star 150 equipment. And it has remembered all of the equipment that I had. And I could create a new one or duplicate the current one if I was moving my computer between different rigs. But right now we're just going to be with one single profile. We can also do some other stuff in there that can be very useful, which is, for instance, have a custom horizon, where you can create a horizon file and import it into Nina so that when you go back to the Sky Atlas and you look at your targets, you have like your horizon visible for each of the targets. And we can do that maybe a bit later. And actually we'll do the horizon for Nina right now because we can and we should. And I'm standing right next to the rig that we are setting up via Nina. So I have my guide camera, I have my main camera, I have the flat panel, I have the mini PC, and I have the mount and the focuser as well. So this is what we've all been connecting. It's always good to go back to the actual equipment that we are working with. But now basically the idea is that I want to have a file that lists a list of compass points, so directions, saying like, okay, true north would be 0 degrees, roughly there. South would be 180 degrees. East would be 90 degrees, west is 270 degrees, right? So what we want to do is have a list of those azimuth angles together with the elevation of my horizon. And there's an app on iPhone devices called Theodolite, I believe, that costs like, what, $14? That can do that for you, but I don't have an Apple iPhone, or any Apple device for that matter, so I cannot use that. But there is a free app that lets us do that, and I'll put the link to that free app down in the description. So this free web app is called Gyrocam, and basically what you'll need to do is you'll set your magnetic declination so that the app can understand the azimuth in relationship with the true north compared to the magnetic north, because they're two slightly different things, and we want the true north. And there's a convenient list of cities there, and Tokyo is -8, so I've put in -8 in there. And then I can tap on the play button. The play button will actually open the camera, and you can see that I have a view of my horizon, so I can pick this point and say we're going to add this point. And at the very top here we have the azimuth and the elevation. So we'll be able to have like a grid of azimuth with elevation when it comes to the horizon. The problem that I have with that is that the azimuth, look at the azimuth, and I'm staying at this in the exact same direction, and yet the azimuth is changing dramatically as I change the elevation of my phone. So it's not very reliable, which means that I have a backup, which is a digital compass on my watch for now. And I'm going to use this digital compass in addition to the elevation that's taken by that. So I would say first point here would be this, and I click the plus button at the bottom here. And for the first point, it tells me azimuth is 120, but I'm going to check with my watch, and my watch says for the same direction, it is actually correct. So 116 from my watch. So, and I've configured my watch to be true north as well. So I'm just going to write down on a piece of paper 116 for point number 1, 116. That way I remember, and I have a double check on the azimuth. Then I can go to the next point of the horizon. Immediately, we go to an angle of 3, so very low angle. I'm going to click the plus button. This time, the azimuth looks very wrong. So again, I'm going to check my watch. My watch tells me the azimuth for that is more like 120. So I'm going to put 120 down on my notepad so I know exactly the angles. Then the horizon is more or less flat for quite a while. It rises up maybe a little bit here, but I'm just going to assume it's flat, and that's easy for me to do. And it's still flat, 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 so we're not changing really the elevation, except here I have a TV antenna that I'm actually not using. But basically, I'm going to take another point here, and it's going to record the elevation. I can check, by the way, by tapping here my list of points. And I'm going to double check with my watch compass that tells me the azimuth is actually agrees with the azimuth there. So we're good. And then we have this area here that tells me I'm going to take another point. Bam. And that's basically all of the points that I need. So that other point that I took, I'm going to check the azimuth with the watch. And again, the azimuth agrees with what the app recorded. So we're mostly good, and I'll have only a few changes for the first 2 points that I recorded with the app. The app told me the first point was as azimuth 121. The real value was 116. And then the second point was at azimuth 88. The real value was 120. So that's why I'm using this notepad. Whenever the app and my watch have a disagreement, I'll be using the watch. And so now from the app, I'm gonna again check the list of points I have. So I only have 4 points because I have a relatively simple horizon to deal with, because most of it is actually relatively flat. And anyway, I'm never going to image less than 30 degrees above the horizon because, well, it's Tokyo and the light pollution is horrendous, especially close to the horizon. I end up with those 4 points. And I just know I need to amend the azimuth for the first 2 points. But then after that, we're just going to be good. And I can copy this using the copy button there as value, or I can save it as a file. And that's what I'm going to do. And I'm going to send myself this file over email so that we can edit it. And once it's edited, we're going to give Nina that file so Nina can work with it. So let's go back to the computer so I can show you how it looks like to import the horizon file into Nina and the impact that it has when we search for a target, and also the impact that it has in terms of Nina understanding the horizon for your particular site. Okay, and here is basically the file that we got. We had like something like as L, something like that at the top, right? So you just remove the first line of the file that is created. And then what I did is here we had another value, something like 88. I replaced it with the notes that I had taken based on the compass on my watch, which was more accurate, especially when I was angling my smartphone. And the way that this works is that we're saying like, okay, at 116 degrees azimuth, the elevation of my camera was 26 degrees up, right? So that's where the horizon is. And then at 120 degrees, so just a short, like very little later, it's at 2 degrees. So that takes care of like this kind of roof that I have right next to my rooftop balcony. Pum, pum, okay? And then I also measured at 357, so almost due north actually, and I kind of take it large because I have this antenna that's like sticking out. I could try to do it a bit better, but anyway, at 357 we have an elevation of 47 degrees, and then at 53 we have an elevation of 42 degrees. Now, the thing here is that what Nina will do is it will trace straight lines between each of those points. And so between an azimuth of 120, which is basically southeast, and an azimuth of 357, which is basically due north, I will have to switch between 2 degrees elevation and 47 degrees elevation. So, which means that Nina would just draw a diagonal line between the two, which is not correct. I want like a straight line like this and then a straight line like that, basically. So I need to add another point saying like, oh yeah, right before my antenna there, at let's say 354 degrees, we're still at 2 degrees elevation roughly. So that means that now Nina will know that between 120 and 354, we have a straight line that is all the time at 2 degrees. And then after that, very quickly, we get to 47 degrees. So I'm just manually adding this little data point there that I kind of effectively forgot to take. So you always need to remember is like we are drawing just straight lines between points. And that's what Nina will do. And once you have that in a text file, so I'm using Notepad, right? So just search for Notepad and open up Notepad, copy paste in there, basically. And I saved it under documents, horizon.txt. That works perfectly fine. So I'm saving that again just to be safe. And then in Nina, what we can do is to go back to the general options there. So options, general. And the custom horizon, I've already set it up with this particular file, but you just browse for files, select your horizon file, make sure you never delete it. You may also want to keep a copy somewhere like on Google Drive or something like that in case you do ever delete it or you install Nina on a new computer, that kind of stuff, so you can just retrieve it back and use it again. And now, if I go to my Sky Atlas and I search for like M31, for instance, you see that I have this green area there that effectively represents my horizon. And I could search for other targets, let's say M32. And again, we have this kind of thing that happens there. And so it's adapted based on the azimuth of the target throughout the night. And now we know when the target will get above my my little like rooftop balconies. Rooftop, I don't know how to explain that, but now we have represented the horizon. And so whenever I'm using something like a sequence, and in sequence, it's going to be spoiler alert for the rest, you have tools like, for instance, wait until above horizon. And that uses your custom horizon if you have one set up. And I could even say like, wait until the target is 5 degrees above my custom horizon just to be safe. I have also like loop while the next target is below horizon. It's going to use again the custom horizon so we can look ahead of time. And I can combine that with a wait for altitude saying like, okay, I want it to be above my custom horizon with an offset of 5, but at the same time, I want to wait until the object is above 30 degrees of absolute elevation. That way, we're sure we have the correct altitude for my target when I start imaging it. And so custom horizon together with the sequencer in Nina gives you a lot of power to really control when you want to start imaging your targets so that you have like the best compromise of altitude, which gives you better signal to noise ratio, especially in light polluted cities. And yeah, I think it's a really cool feature to have, and it's the kind of stuff that I would love to have in the ASI Air. And one more thing on this general tab is the Sky Survey cache folder, which has a default value that is not where we put the cache. So you can just click on those 3 dots, and for me, I had put it under Documents. I'm just going to put Framing Assistant Cache, select folder. So now this is set up, which means that if I go back to my Sky Atlas and select whatever targets, let's say M31, here we go, we now have some image of M31 on the target. Anything like really should have some images in there. So we have some idea of the image that we're taking. So Caldwell 11, that kind of stuff. So now it's installed and ready, and we can use that in the Sky Atlas to have a good idea of exactly what we're imaging. Then we can go to the Equipment tab. The Equipment tab is important because that's where you have your camera settings. You want to make sure that they are correct. So in this Equipment tab, you have your camera settings, but you also have your telescope settings. So I'm just going to say this is the CS150. The focal length is 570 millimeters. The focal ratio is f3. Which is actually 3.8. And the most important thing here is the focal length, because that's going to be used in plate solving. And another very important thing that's used in plate solving is the pixel size. Typically it gets it automatically from the camera, but if it doesn't, make sure that it is accurate. Then I can put my mount name. This is WD20. And the default parameters should be good, so you don't really need to care about that. Then we have, like, if you want to have like weather within Nina, you can have an open weather map API key. I'm not going to bother with that in this particular guide. You could also connect to an external planetarium software, but again, we haven't installed it. ASCOM Alpaca Discover, you can leave it as is. But here, we can change the name of my filters for the filter wheel, which is going to be very useful because I have in filter 1 a dark filter, then it's L, R, G, B, H, S, and O. There I have all of my filters properly renamed. If I quickly go back to my filter wheel, you can see that now they're properly renamed and I can choose a filter to go to. So I could say like, hey, go to the red filter, and it's switching filters to the red filter. I could go to my imaging tab, by the way, and I have here the filter wheel, and I could say like, okay, it's changed to the blue filter, and switching filter, and change to the dark filter. But of course, all of that is fully controllable within a sequence as well. Then we can go into the autofocus settings. Now the autofocus settings, we don't really want to touch them that much right now. We do want, maybe the only thing we can do right now properly is to set a default autofocus exposure time, which is 4 seconds by default, which works for most rigs. I would leave it as is, except for my narrowband filters. I have HSO filters, right? Maybe for them, I will double the exposure time to 8 seconds, just to make sure I have enough exposure time to detect the stars with those filters. And one thing that is very useful with Nina, and we have a plugin that will help us with that, and I'll probably cover that in the plugins, is that we can set up filter offsets. For instance, if my luminance filter is perfectly in focus at position 5000, and my red filter is perfectly in focus at position 5005 in terms of absolute value, then I set them up like that, and if I say use filter offsets there, Nina will basically, if I switch Nina from the luminance filter to the red filter, Nina will move the focuser automatically by 5 steps. And so if you know the exact focus point for each of the filters and you put it in there, including for the dark filter, because if you put 0 in the dark filter, it's going to be a disaster. So you want to put something like same value as L for the dark filter in my particular case. But you put all of the values in there with filter offsets. It means that you can switch between filters. And if you were properly focused to start with, as you switch between filters, you will not have any need to do further autofocus. It will just move the focuser by the exact number of steps required to still be in perfect focus with your next filter in the sequence. So that's great because if you're in a sequence, instead of doing like 2 hours of L, then 2 hours of red, then 2 hours of blue, etc., you can do 1 luminance, 1 red, 1 green, 1 blue, back to 1 luminance, red, green, and blue without doing any autofocus in between because you're able to just use these filter offsets, and it's very, very powerful. And there is a plugin that lets you actually compute the offsets automatically and set them up in there automatically. Also, once you use filter offsets, you can say that the luminance filter should always be used as the autofocus filter. So I can select the luminance filter, click on Set as Autofocus Filter, and what is going to happen is that, let's say I'm doing SHO, actually I just realized my my filters are incorrect. It's going to be SHO, not HSO. Boom, there we go. Let's go back to autofocus. But let's say I'm imaging with hydrogen. I'm imaging with hydrogen throughout the night. But I do an autofocus. Rather than waste the time doing very long exposures for autofocus with the hydrogen filter, Nina will go to the luminance filter, do the focusing with the much shorter exposures with the luminance filter, and then go back to hydrogen alpha using the offset to make sure that we're still in focus. It's very powerful, and I do believe it's a feature that I added to Nina because, yes, I used to be a contributor developer for Nina. One of the other things that I recommend doing while we're on this tab is to set the curve fitting strategy to trans and parabolic. This is the one that I feel works the best. At least for every telescope that I've used, it seems to work the best. And I'm kind of the one who developed those parabolic fitting and hyperbolic fitting in the first place. Another thing that we'll be able to set up later down the road is a backlash compensation method, which is if you know your focuser backlash, you can set up in either direction. By default, it's overshoot, and we'll leave it like that. You'll want to make sure to set up a value that is higher than the actual backlash of your focuser. And typically, for most focusers, I like to put the autofocus step size, which we're going to figure out later on under a night sky. But I take that, multiply it by 10, and put it under out. But we can do that a bit later once we have a starry sky, so I can show you how to really do the final touches on the autofocus for it to completely work. Okay, we don't have a dome, so we can skip to imaging. And under imaging, what I like to change is the image file pattern. Here you can see that it would put date, then the type of frame, then the frame itself with a certain name in there. And instead of date, I like to have the target name. So what I'll do is I'll just go to this, and you see this date minus 12 like $. I can remove that, and I can search for target name, which is here, and drag and drop target name to the very start here. And now it's going to save target name, type of frame, and then the frame itself. And if you want more information, like the focuser temperature or the guide RMS for that particular exposure, to figure out if you had exposures with poor guiding, so I could have that in between the exposure time and the frame number. So I could drag and drop the RMS, bam, and set it up here. Now, just by looking at my frame RMS, I can check whether I have frames with really bad guiding, and then delete them before I start stacking them. So that's very powerful in terms of how the files are saved. And then we have the Meridian Flip. So for Meridian Flip, it really depends a lot on your mount. And by the way, it reminds me, there's one setting in PhD2. If you go to the brain, if you go under guiding, you have a reverse deck output after Meridian Flip. And for on-step drivers, on-step mounts, typically it needs to be on. I believe that for Green Swamp server, it also needs to be on, but for most mounts, it can stay off. If you ever see that you have issues with the guiding, especially after the Meridian Flip, suddenly everything goes haywire, you can set that up. And I believe there's an equivalent setting in the ASI Air. But here we can say, in terms of the Meridian Flip settings, where the default settings are that we are going to do the flip 5 minutes after the meridian, or up to 10 minutes after meridian, depending on what we're doing at that particular time. And we are going to recenter after the flip, and we could also say hey, I want to do some autofocus after the Meridian Flip, if that works better for your particular needs. Or you can rotate the image if you have a rotator by 180 degrees after the Meridian Flip, if you wish to do so. So for that to work, you need to make sure that your mount settings are correct in terms of limits, so that If you track through the meridian, you need to make sure that the mount will not hit a limit before 10 minutes after meridian. Otherwise, you may want to set up your mount to stop tracking 5 minutes before the meridian. There's all sorts of stuff there. It really depends on your mount, but I recommend doing some tests during the day to make sure that the meridian flip is going to work, or wait until there's a full moon so that you don't really waste imaging time, and under the stars you make sure that the meridian flip works, and you just like slew to a star that's about to go past meridian, start a sequence, see if the meridian flip works, and if it does, great. If it doesn't, change it until it starts working. That's probably one of the more delicate things, and it depends a lot on your mount and your mount settings, but I guarantee you can get it to work. Like the easiest to make sure that it always works is that you can say like pause 5 minutes before meridian and then flip 5 minutes after meridian. That's typically going to work fine as long as your mount limits are okay with that. That is the settings that I recommend if you ever have issues with the meridian flip. I like to set that to 0 because then it doesn't pause at all and it keeps imaging through the meridian. And the meridian is the best quality of images that you get, so I don't like wasting that time. And I'm set up so that my mount will keep tracking through the meridian while exposing, and then Nina will do the flip between 5 and 10 minutes after the meridian has been crossed. Now, all of the settings for now we can leave as is. You can, if you ever have trouble with autofocus, change the noise reduction there to normal or even high, depending on whether you have issues, but the default settings should work reasonably well. Okay, and now we can go to the last step, which is plate solving. And plate solving, you can see that it's set to ASTAP by default, and you can set your exposure time, like let's say 4 seconds, for plate solving, and you could also select a filter that you want to use with plate solving. And if I recommend using the luminance filter, if you have a filter wheel and you've set up your filter offsets. If you don't have filter offsets, just select current, and that's going to be fine. You could change the gain as well of your camera if you needed to, and you can also change the pointing tolerance, like how many arc minutes of error are you allowing. But typically those default settings work perfectly fine. And the only thing you need to do is for ASTAP, it's preset. So it's like I've already got an ASTAP installed, the catalog installed, ASTAP is set up there. Plate solving is basically ready to go, nothing to do. And you could also, if you're using PlateSolve 3, you would need to just select the PlateSolve 3 file location where you installed it, and make sure that you select PlateSolve 3 in both of those boxes. But for us, plate solving is ready to go without us doing anything in particular. And now we can go to the next tab, which is the plugins tab, and this is where third-party plugins are available for Nina to make it even more powerful. So we can click on available. It should list a list of plugins available. For instance, if you want to control your Nina instance remotely using like third-party smartphone apps, for instance, you could install the advanced API. If you want to do polar alignment from Nina using 3-point polar alignment, you want to go to this 3-point polar alignment plugin and click install. If you want to be able to connect and disconnect your equipment within a sequence, you can go to a connector and click install. If you want to have a tool that will compute your filter offsets automatically, which I do, you want to go to this filter offset calculator and click on install. If you want an alternative autofocus algorithm called Hocus Focus, you can click on that and click on install. And each plugin has its own kind of instructions in there. And you have some other cool plugins, for instance, Remote Copy, that lets you automatically copy the files that Nina saves to a remote computer on your network for processing directly afterwards. And all sorts of plugins are available. I'll cover a few more later in the video. Once you've installed them, you can click on Requires Restart. This will restart Nina, and you'll be able to access your plugins. So for instance, if I go to imaging, you'll see that in the top right, I have more icons than I used to have. And one of them is this icon, the 3-point polar alignment. So I can add that And we have it available here, and we can use the 3-point polar alignment for Nina to polar align our mount. Another of the plugins, you can see if I go to the options and imaging, now I have star detector, annotator, and autofocus. I can choose Nina or Hocus Focus, the new plugin that I installed. Others are available within the sequencer, so we'll look at that in a moment. One of the other plugins that I really like, by the way, which is available in the sequencer, is the Orbiculum plugin that basically lets you tell Nina, like, hey, image this target until the next target in the sequence is above 30 degrees above the horizon, whatever, something like that, right? So that it doesn't depend on the current target, but on the visibility of the next target. There's something very similar called target planning that lets you completely let Nina take over everything, and you don't need to create sequence anymore, but we won't cover it right now. It's a very advanced plugin, and it lets you be really, really lazy. Okay, so that's it for the initial Nina setup. Next, I want to wait for a clear night so I can show you how to set up the autofocus, how to do plate solving, how to do my first Meridian Flip, my first sequence, etc. There's a lot of stuff to learn and to have fun with. So let's keep going on that. And by the way, obviously, this is a lot of work, so if you want to support the channel, you can like the video. It really helps it out. And if you have tips and tricks on Nina, you can go down in the comments, or your favorite plugin, whatever. Let us know down in the comments. I'd love to see your thoughts. And if you want to support the channel even more, and you're planning on buying anything from Amazon, including non-astro stuff, Agena, High Point Scientific, etc., if you do so after clicking one of the links down in the description, it will help me out at no cost to you. And if you want to sponsor those videos, make these videos possible directly, you can become a channel member. This is the join button next to the subscribe button, or you can become a Patreon supporter, and I have the link down in the description. Some of my Patreon tiers have access to my videos early and without ads. And you guys, you know it, you make all of this possible. Thank you so much for your generosity and for your support. With that, let's go and wait for a starry sky, which with the rainy season here in Tokyo might take a while. And then we can have a look at how to use Nina in practice, have autofocus working, plate solving working, Meridian Flip working, sequencing everything. It's gonna be amazing. So let's get to it.